Okay, Math 098, we're continuing on with more properties of logs. This is section 6. And each one of these properties is slightly different. But what they're trying to get you to realize is that you can separate logs. It makes the math a little bit easier. So it's all based off of our rules of exponents. I don't want to get into too much detail and make this video super long, but feel free to Google why the product of logs gets separated like this, and you'll get an explanation dealing with exponents. So the main thing is, if you're multiplying inside of a problem like this, you can split it up as log base b of x plus log base b of y. So notice the multiplication turns into plus. And just think for a second, if we were multiplying two bases, that are the same, we join them together with addition. So this rule that we've learned before is really the same thing that we've done here. Whereas this quotient rule, here we go, is really the same thing as dividing with the same base. If we had b to the m over b to the n, that would be combined together as b to the m minus n. So I hope this is making sense, that if we have log base b of some sort of quotient, I know it looks weird because the y is below the b, but that's the formatting of this program. You split it up using subtraction. And we have this new rule with a power in here as well. I don't know why the book uses r as the power, but they do, where you can move this power in front. Sometimes I'll explain this rule by using the product rule, because let's say I gave you a problem that was like log base b of x squared. Well, that's the same thing as log base b of x times x, right? Agreed, x times x is x squared. Well then, if we use our product rule, then we could say that's the same thing as log base b of x plus log base b of x. Well, how many log base b's of x do I have? I have 1, 2 of them. So it makes perfect sense when you examine a few problems why you can just take that power and slide it in front. And at some point, you'll probably use these so much that it'll become second nature, and you won't even think about why these rules are true. You just know that they are, and you just keep doing them. So by the way, we sometimes separate logs this way, and sometimes we join them together into a single logarithm. So let's look at some examples. And that's exactly what we're doing with the first one, is we're combining them together as a single log. So the key here is the addition. We can write it as a single log because the bases are the same of 5 times 3. So this answer that I'm looking for is log base 8 of 15. Now here's the thing, is you can use a calculator. I've never asked you to take a no calculator test. But if you leave your answer, let me clear that out. Let me use my log base 8 of 5 plus log base 8 of 3, and you give me this decimal answer, I'm going to mark it wrong because that's not a single logarithm. But you can check that you have the right answer by typing in log base 8 of 15, and you get the same decimal, so you know you did it correctly. So that's what I mean by feel free to use a calculator to help you understand the rules. Okay? So same thing goes with the next one. Just writing as a single logarithm. And I think you probably noticed that all 3 of these first ones are addition. So it makes perfect sense that we're kind of going in order, that we're doing the product rule first. Well, 1/3 times 18 is 6. And that's all I expect to see you write down, log base 2 of 6. So as we look at the next one, again, we have this addition, so we need to multiply. Now here's the thing, and this is why this is chapter 9 now, is as we're multiplying, it is, you have to FOIL this. You have to use the distributive property, x squared times x minus x minus 1. So you do have to FOIL this. So the answer I'll be looking for is log base 5 of x squared minus 1. And it's nice if you put in parentheses there. So that's the kind of answer I'll be looking for. Make sure that the bases are the same. If the bases are not the same, these rules do not apply. All right, you cannot do these rules if the bases are different. So as I look at the next one, you notice that we are switching over to subtraction. So what that means is we have log base 5 of 18 divided by 6. And yes, the order matters. 18 divided by 6 is not the same as 6 divided by 18. So the answer I'll be looking for is log base 5 of 3. But again, feel free to use a calculator to double check that you have the right idea down. Now, sometimes there's not much to do. You know, as you look at this problem, we can combine them together, but I don't know what x divided by 3 is. I don't know what x is. So this is all you can do on this middle problem. And then the same thing goes for the last one. This is kind of a weird problem. But make sure the bases are the same so that you could combine them. The fact that it's subtraction means that we can combine them using division. Now here's the other thing is sometimes, not very often, but sometimes we give you problems that can be factored. Neither of these can be factored though because they're sum of cubes, they're sum of squares. But sometimes we can cancel things out, so be on the lookout for that. And then the last exercise on this slide is practicing that power rule, where you can bring the power in front. This is all they're trying to get you to recognize. 8 log base 7 of x. Now, let's do some manipulation here. Please don't forget that the fourth root is the same thing as 7 to the 1/4 power. So now you can still use the power property of bringing that 1/4 in front. Log base 5 of 7. So this is the answer I'll be looking for if this shows up on a test, when it shows up on a test. So feel free to hit pause. I know I went pretty quickly over this, but it's only 3 rules. I think you can handle that. And as I move forward, we can combine things with multiple rules. So notice in this problem that now we're going to go backwards with the number that's in front can be switched over to be a power. So we're looking at log base 5 of 4 squared. Do you think you can do this all in one step? I think you can. Because it's addition, we can combine them using multiplication. And I'm also going to make that 5 be that exponent, 2 to the 5th. So what does that mean? Is that we're looking at log base 5. Well, 4 squared is 16, and 2 to the 5th, 2, 4, 8, 16, 32. There's 5 2's there. I'm really bad at math. Sometimes I just forget. 16 times 32, 512. So the answer that they'd be looking for is log base 5 of, I already forgot what the number was, 512. Cool. So as we look at the next one, and maybe I'll slow it down. I don't know if this is too difficult for you, but I see a number in front, so I'm thinking that that's going to be log base 8 of x squared. I see a minus here with the same base, so I can combine them using division. And then x plus 3, okay, that'll go into the denominator then. And you don't have to put parentheses just around that if that helps you understand, because there's nothing left to do. You know, as long as you can change 2 to be squared, x to be squared because of that 2, there's no coefficient in front of this log, but the minus makes it into a division. And that's the thing, is we can do a combination of things. I'm trying to think of common mistakes I've seen in the past. And you can do this piece by piece. Just make sure that the bases are the same. So what I would tell students is just make sure that if you are adding, the very next term goes into the numerator. So it's 12 times 5. And when you're subtracting, it's only the very next term that goes into the denominator. What I'm talking about here is I've had students in the past, maybe, let me just give you a fresh problem real quick, is they do log base 2 of 5 minus log base 2 of, I don't know, 3, and then plus log base 2 of, I don't know, 15. I'm just making up numbers. So this one condensed down would be log base 2. 5's in the numerator because it's a positive term. The 3 is in the denominator because it's a negative term. See what I mean by only immediately following? And then the 15 would go into the numerator. And then obviously I'd want you to simplify that to be, log base 2 of 25 if I'm doing my math right. Whereas this one, if I do my math correctly, is equal to log base 7. Let's see, 12 divided by 4 is 3 times 5 would give me 15 there. So some common mistakes. This is just a made-up problem off the top of my head that I've seen a lot of students do incorrectly. So looking at the next one, really the same thing, and I've seen students do this incorrectly, but just split them up. We're looking at log base 5 of 4, because it's in the numerator, plus log base 5 of 3. 3's in the numerator, but 7's in the denominator, so I'm going to make it minus log base 5 of 7. And that's the answer I'm looking for on exercise 5. If you are coming up with any questions, please write them down. So I'm going to do this next one very slowly, because as I'm looking at this, I'm just going to rewrite as log base 4. I'm going to leave it as a squared for now. The division here makes me have a minus log base 4 of b to the 5th. But we need to do one more step, and that one more step is moving the powers in front. I know the directions don't really say it, sums or differences. This is the key phrase of multiples of logs. That means they don't want exponents. So the answer that we're looking for is 2 log base 4 of a minus 5 log base 4 of b. All right. Again, pause the video, write down things, make sure you understand before you attack the homework. And here's the thing is, we can have, I know that some people would try to figure out what the base is so they can use their calculator. That's fine. It's just more beneficial if you think about, well, how can I change 15 to be, something with 5 and 3? So if you think of it this way, the problem's not that bad. Well, 5 times 3 is equal to 15. So what they're trying to get you to think about is, well, how about we rewrite this as log base b of 5 plus, because of the multiplication, log base b of 3. Well, based off of the directions then, log base b of 5 equals 0.83, and log base b of 3 is 0.56. Well, if I add those together, and again, feel free to use a calculator, 0.56. You get the correct answer of 1.39. It's just a matter of, can you think of a way to use 5 and 3 to get to that number? Can you think of a way to get, well, how about this? This is the same as log base b of 5 squared. Well, now, because 5 squared is 25, I can rewrite this as 2 log base b of 5. Well, that's equal to 2 times 0.83. Well, that's equal to 1.66, if I did my math right. I'm trying to hurry, I'm running out of time. So the last one, rewrite this as log base b of 3 to the 1/2 power. So I can move that 1/2 in front. Half of log base b of 3. half of 0.56 is 0.28.